A very good morning, students. From now onwards, we will be discussing on psychrometry, which is unit 4. Let us have a glance on concept of psychrometry and psychrometric. We know that air comprises of fixed gases, principally nitrogen and oxygen, with an admixture of water vapor in varying amounts. In atmospheric air, water is always present, and its relative weight averages less than 1% of the weight of atmospheric air in temperate climatic conditions, and less than 3% by weight under the most extreme natural climatic conditions. It is nevertheless one of the most important factors in human comfort and has significant effects on many materials. Now, let us try to define the definition for psychrometry and psychrometrics. The art of measuring the moisture content of air is termed as psychrometry. I repeat, the art of measuring the moisture content of air is termed as a psychrometry. The science which investigates the thermal properties of moisture considers the measurement and control of the moisture content of air and studies the effect of atmospheric moisture on material and human comfort may properly be termed as psychrometrics. Now, let us try to understand some important definitions regarding psychrometry. Let us try to define dry air. The International Joint Committee on Psychrometric Data has adopted the following exact composition of air expressed in mole fractions, volumetric fraction. Oxygen is about 0.2095, nitrogen is about 0.7809, argon is about 0.0093, and carbon dioxide is about 0.0003. The traces of rare gases are neglected. So molecular weight of air for all air conditioning calculations will be taken as 28.97. Okay, the molecular weight of air for all air conditioning calculations will be taken as 97. Hence the gas constant will be ideal gas constant for air is gas constant for air is 8.3143 divided by, which is ideal gas constant, divided by 28.97. This is molecular weight of 28.97 is molecular weight of the air, and hence the gas constant of air is 0.287 kilojoule per kg Kelvin. Natural air, sorry, dry air. Dry air is never found in practice. Please have a look at here. Dry air is never found in practice. Air always contains some moisture. Hence, the common designation air usually moisture. Whenever we use the word simply air, that means it is a moisture. So the term dry air is used to indicate the water-free contents of air having any degree of moisture. Okay, unless and until it is mentioned it is dry air, you should assume it as air itself, which means you should assume it as moist air only, unless and until it is mentioned as dry air. If you mention it as a dry air, then only it is dry air, which means that it is completely free from moisture. But naturally it is difficult to find complete dry air in practice. So that is why whenever in the problems we mention the term air, it means that it is a moisture. Saturated air. Moist air is said to be saturated when its condition is such that it can coexist in natural equilibrium with an associated condensed moisture phase presenting a flat surface to it. For a given temperature, a given quantity of air can be saturated with a fixed quantity of moisture. The meaning of the sentence here is, for a fixed temperature or for a given temperature in a air, we can have a fixed amount of moisture content for a given temperature. More than that we cannot have. If the moisture content in a air or in a moist air will be fixed for a particular temperature, temperature and pressure. If the temperature exceeds or if the moisture content exceeds, then it will start condensing. So saturated air is nothing but it is the condition of a air, or it is a condition of a air which signifies the maximum moisture content that air can have. That is what the saturated air, the meaning is. At higher temperature, it requires larger quantity of moisture air to saturate. Okay, if the temperature of moisture is higher, then it needs more moisture content to saturate it or to equilibrium with it. At saturation, at saturation condition, vapor pressure of moisture. I repeat, at saturation, vapor pressure of moisture in air corresponds to the saturation pressure given in steam table, correspond to the given temperature here. So overall, or generally, overall meaning of saturated air means for a given temperature, we can have fixed amount of moisture in a moist air. Okay, so that is what called the saturated air. Saturated means it is equilibrium condition or maximum moisture content that air can have in a given temperature called saturated air. Dry bulb temperature, or we can call it as DBT in short. It is the temperature of air as registered by an ordinary thermometer is called dry bulb temperature. In the figure you can observe here, okay, this is a thermometer by which you will observe the temperature is called dry bulb temperature. Okay, if you measure the temperature using this normal temperature is called dry bulb temperature. Now wet bulb temperature, we will call it as a WBT. It is the temperature registered by a thermometer when the bulb is covered by a wetted wick. Okay, you can observe in the figure B here. Okay, dry bulb temperature is temperature measured by normal thermometer, but wet bulb temperature is, it is a temperature which is measured by a thermometer whose end is covered by a wetted wick. Wetted wick means it is cloth which is filled in water. Okay, wetted wick means it is a wetted cloth it is, and is exposed to a current of rapidly moving air to which the temperature is measured. Okay, so dry bulb temperature is the temperature measured by normal thermometer is called dry bulb temperature. Wet bulb temperature is temperature which is measured by a thermometer whose bulb is covered by wetted wick. And what is the difference here is, okay, this end of thermometer is not covered by anything. Okay, once air is comes in contact with this and it shows the temperature, but here the end of this thermometer bulb is covered by wetted wick. Once the air of which we need to measure the temperature comes in contact with this wetted wick, what happens is, whatever the wetted wick is there, water content in there now, that will be evaporating. Okay, so then once that evaporates, it cools the bulb. Once the air comes in contact with this wetted wick, what happens is, water content in the wetted wick or that cloth material will be evaporating. Once it is evaporating, it cools the bulb inside. That is why it registers lesser temperature than the wet bulb temperature. In wet bulb temperature, what happens, very important thing here is the evaporation from the wetted wick. Okay, the evaporation from the wetted wick is reduced when air contains more water vapor. Okay, I told that the once the air comes in contact with this wetted wick, it starts evaporates. Once the water contents in the wetted wick starts evaporates, it cools the bulb of the thermometer and hence it registers less thermometer. And one more thing is, the evaporation of this wetted wick water vapor reduces when the air contains more moisture. Okay, so that is the difference here. And now adiabatic saturation temperature, it is the temperature at which water or ice can saturate air by evaporating adiabatically into it. Okay, once again I will read out. Adiabatic saturation temperature is the temperature at which the water or ice can saturate air by evaporating adiabatically into it. It is numerically equal to the wet bulb temperature itself. Now, wet bulb depression. Wet bulb depression is the difference between dry bulb and wet bulb temperature. Okay, wet bulb depression is difference between the dry bulb and wet bulb temperature. One thing you should observe here is, always dry bulb temperature will be more than wet bulb temperature. And last one, which is dew point temperature, DPT. Dew point temperature is the temperature to which air must be cooled at a constant pressure. In the third diagram you can observe, Dew point temperature is the temperature to which air must be cooled at a constant pressure in order to cause condensation of any of its water vapor. It is equal to steam table saturation temperature corresponding to the actual partial pressure of water vapor in the air. Dew point depression, it is the difference between the dry bulb temperature and dew point temperatures. Okay, it is called dew point depression. Now specific humidity or humidity ratio, it is the ratio of the mass of water vapor per unit mass of dry air in the mixture of vapor and air. Okay, I repeat, specific humidity is the ratio of mass of water vapor per unit mass of dry air in the mixture of vapor and air. It is generally expressed as grams of water per kg of air. Okay, it is specific humidity is nothing but it is the amount of water or grams of water present in per kg of air. That air will be mixture of what? Vapor and air. For a given barometric pressure, it is a function of dew point temperature alone. Okay, it depends on the dew point temperature itself. Now relate to humidity. The sign is pi, or you will call it as RH, relate to humidity. It is the ratio of partial pressure of water vapor in the mixture to the saturated partial pressure at the dry bulb temperature expressed as percentage. Relative humidity is, it is the ratio of partial pressure of water vapor in the mixture to the saturated partial pressure at the dry bulb temperature expressed as percentage. Then sensible heat, it is the heat that changes the temperature of a substance when added or abstracted from it. Okay, sensible heat is the heat that changes the temperature of substance, but it won't change the state or pace of a substance. Now latent heat, it is the heat that doesn't affect the temperature but changes the state of substance when added or removed from it. Now enthalpy, enthalpy is the combination energy which represents the sum of internal and flow energy in a steady flow process. It is determined from an arbitrary datum point for the air mixture and is expressed as kilojoule per kg of dry air. Note that when the air is saturated, then dry bulb temperature, wet bulb temperature and dew point temperature will be equal.